Good afternoon, students. Today we can discuss about the phototransistor in the electron devices and circuit theory subject. So, what is a phototransistor? Is an electronic switching and current amplification component which relies on exposure to light to operate. So, the base region is exposed to illumination. So, which is exposure to light means which region is illuminated? The base region is illuminated, and it is invented by William Shockley in the year 1951. And this is the structure of the phototransistor with two terminals. So it is available in both PNP and NPN types, having different configurations with common emitter, common collector, and common base. But generally, we are preferring the common emitter configuration. So this particular phototransistor operates whenever the light falls on the junction. Reverse current flows, which are proportional to the luminance. The phototransistors are used extensively to detect light pulses and convert them into digital electric signals. So these are operated by light rather than electric current. This is the major difference we can say from your normal PNP and NPN transistor. So it is also called as photodiode. It is much more sensitive. So it is a semiconductor photo device than your PN junction. And it is commonly, it is a light dependent resistor. We can say other one we can say. So what is that light dependent resistor? Similar way to photoresistors commonly, which you have studied already, but are able to produce both current and voltage, while photoresistors are only capable of producing current due to change in resistance. So that is the actual difference from photoresistor. So photo transistor can able to produce both current and voltage. So the current produced by photodiode is very low, which cannot be directly used in normal control applications. But this current should be amplified before applying to the control circuit. So there is it will be active. So this phototransistor is a light detector which combines photodiode and transistor. Is a bipolar transistor, can also be used as a photodetector. So when phototransistor is illuminated, it permits a larger flow of current with high gain, and this is the symbol. So some NPN, PNP told as three terminals, but the base is illuminated towards the light, as you see in the diagram. So NPN, PNP, base region is not separately shown. It is actually illuminated to light. There is nothing but the input. Okay. So instead of sending current into the base, the photons from striking light activate the transistor. This is because a phototransistor is made of a bipolar semiconductor and focuses on the energy that is passed through it. Okay. So this is the construction part. You have a collector region, and the base region is the P type, N type. So N is the emitter, in which the base region is illuminated with light. So this is nothing but it's shown as NPN type. And this particular thing, we see the base region is made open. Compared to the conventional transistor, it has more base and collector areas compared to the emitter. So ancient phototransistors used simple semiconductor materials like silicon and germanium. But nowadays, modern components use materials like gallium and arsenide for high efficiency level. So the base is the lead responsible for activating the transistor here in the structure. It is the gate controller device. We can say the base as a gate controller device. The collector is the positive lead and the larger electrical supply. The emitter is the negative lead and the outlet for the larger electrical supply. So we can discuss about the operation. So when there is no radiation excitation, what is the meaning of that? When with no light falling on the device, there will be only a small current flow due to thermally generated whole electron pairs. Whenever a p-n type is in pitch together, there will be, that normally the whole electron hole recombination starts. Okay, so there will be a small flow of current. And it will be slightly less than the supply value due to the voltage drop across the load resistor. So when with light falling, now you comes to the point with light falling, that's when light is turned on. What happens on the collector base junction? The current flow increases. With the base connection open circuit, the collector base current must flow in the base emitter circuit. and hence the current flowing is amplified by normal transistor operation. Okay, so additionally, the minority carriers generated is equal to the total current as you are calculated in the total current 1 plus beta into ICO plus I. What is IL? That is the reverse saturation current due to the light. So the phototransistor is 50 to 100 times more sensitive than a photodiode with a lower level of noise, and it has a high current gain. So how it is going to work based on these characteristics, we can say it activates once the light strikes the base terminal and the light triggers. So slightly starts to increase. Okay, and the what happens when the current increases? Then it is concentrated as well as changed to voltage. Generally, a transistor doesn't include a base connection. This base terminal is disconnected as the light is used to allow the flow of current to supply throughout the photo transistor. Okay, so it can be used normally with the BJT type and FET type. What we have discussed is BJT type. And what are the applications? The major applications are light detection system, light operated switches, level indicators, and relays. So mainly it produces more current, and so it is used with a very much higher advantages compared to the photoresistor. So the major advantages are produce a higher current, relatively inexpensive, very fast, and produce a voltage. What are the disadvantages we can say is it can handle handling voltage over 1,000 volts is very difficult. And because some surges, spikes will be happen whenever there is a change of fluctuations in the current. And it is not at all used in electron tubes, mainly RF devices. It can't be used. So major applications also include punch card readers, then electric controls, lightning control, then counting systems, level indication, relays. These are the commonly used applications. That is the phototransistor is used. So we have discussed about the phototransistor. What is a phototransistor? What is the construction of the phototransistor? And how it is going to operate with the two conditions: when no light, when our light is illuminated. And based on that, the characteristics we have discussed, then the advantage, disadvantage, as well as applications. Hope you have understand. Thank you.